Thank you for coming. My name is Patrycja, and today we are going to explore live Kubernetes hacking together. So get ready for a ride. But first, a brief introduction. I've been doing professional software development for over 25 years, so that's a quarter of a century. That's impressive, isn't it? I must say that I still love it. I've always been close to code, and that bond still thrives today. However, 2 years ago, I joined the dark side of platform engineering at Forum 3. So now I'm a staff SRE engineer, and that's it. What are we doing at Forum 3? Forum 3, in short, is a financial cloud. So basically, we provide a payment as a platform model to make integration with different payment schemes easier and less time-consuming for our customers. We are fully remote, cloud-based, with microservices-based architectures. Recently, we've built this new multi-cloud payment platform, which is based on Kubernetes and 3 clouds. So obviously, Kubernetes security is super important to us. What am I going to talk about today? Just a splash of theory in an ocean of practice. The key part of today's talk includes 3 to 4 demos, depending on time. So basically, I'm going to hack your accounts and get access to your secrets, exploiting various security misconfigurations in a Kubernetes application as well as a Kubernetes cluster. Before the fun begins, let's have like a brief introduction to Kubernetes architecture, just for all of us to be on the same page and to see which components we could attack and exploit in practice. So there is 2 main concepts in Kubernetes: control plane nodes and worker nodes. When it comes to control plane, basically it manages the entire cluster. We have several components here, like etcd, scheduler, but the heart is the API server. So basically, if you want to create or update a resource in your Kubernetes clusters, you need to interact with this API server. So this is like a HTTP-based API, and we can make use of it using various tools like kubectl. Who knows kubectl? Yeah, most of you. So etcd is also super important. Why? Because etcd basically stores all information on all your resources, Kubernetes resources. So basically the entire state of the cluster. So once you get access to etcd, you can, for example, read some secrets. On the other hand, we have worker nodes. So worker nodes are the place where the actual work happens. The actual pods are running over there. And here we have a similar component as on the control plane side. So we have kubelet, who basically is responsible for instantiation and execution of pods on a node. Similarly to the API server, kubelet also exposes an HTTP API, but this is only an internal API. Think about this, that we could exploit unsecured kubelet API to get access to the node and pods running over there. Another important concept for hacking in Kubernetes is networking. So basically, Kubernetes has this flat network model, which allows for each pod to communicate with any other pod by default. This is implemented via CNI, container network interface. This is only a specification, an interface, so we have different implementations here, like Calico, Cilium, or Flannel. And basically, underneath, all of them work the same way. They create kind of an overlay network to allow this communication. And this network is usually created via creating virtual network interfaces on a host, and then some sort of forwarding via IP tables or eBPF injected rules to forward the traffic to a right pod. So basically, what's important is that we have virtual network interfaces on a host, even though those belong to actual pods running on Kubernetes worker nodes. What can go wrong here? A lot of things, believe me. Who knows OWASP? Yeah, a lot of you. So OWASP stands for this Open Web Application Security Project, and that's a non-for-profit organization which aims at increasing security awareness among developers. And they are pretty well known from those top 10 security risks list. It all started with web application security. During all those years, they introduced many other technologies with those top 10 security risks. And only in 2022, for the first time, they published this list for Kubernetes. And that's like a hit parade. So let's get a look at the chart toppers. So number one is what we are going to focus today is insecure workload configurations. So many ways of deploying our workloads into Kubernetes with some sort of insecure configuration. It may be like root user, writable file system, or parameters like privilege, host path, or host PID. So a lot of them. Obviously, usually to exploit and compromise a system or an account, it's not enough to have a single vulnerability. Usually you have like a bunch of them working together in favor of hackers and to get like a successful exploit. From the security point of view, Kubernetes point of view, it's important to mention lack of centralized policy enforcement because it works together with insecure workload configuration. So you need some sort of a mechanism which denies creation or update for resources with insecure configurations. We also have missing network segmentation controls. That's also super important in the context of Kubernetes. Why? Because I mentioned this flat network security model. So if you are running different workloads, separate workloads in a single Kubernetes cluster, you should think about some network segmentation just for your workloads, not to communicate with each other. Otherwise, it may be like one vulnerability in a single workload can lead to a compromise of another workload, for example, more sensitive one. So also in terms of Kubernetes, it's important to mention secrets management failures because secrets in Kubernetes are not encrypted, they are only encoded. So it's important to mention that because you don't get this security by default out of the box. And obviously some misconfigured cluster or Kubernetes components. So I think those are super important. The other ones also, but they are more on the configuration side, like you need to make sure that you have right permissions configured. You need to make sure that your supply chain is secure and nobody malicious can like poison it and inject insecure workloads. So obviously we are focusing on this number one today. And there is another threat matrix for Kubernetes. This one is based on Mitra attack framework. This is like de facto security standard for modeling threats in systems. And this one was published for the first time in 2021 by Microsoft. And as you see, this one is like more technical one, focusing on different phases of successful attack and different mechanisms you can use. For example, for initial access, initial access can be done via leaked kubeconfig files, via some application vulnerability, via exposed sensitive interfaces. So obviously those two resources are super valuable and highly recommend to get to know them. But let's move to our hacking. That's going to be like 101 course in Kubernetes hacking. So that's to explain the basics to you and hopefully to show you how a series of simple misconfigurations can lead to a total compromise of a cluster. So it's time for the fun. I have this demo application available at javaday.yonlabs.com. You can scan a QR code, and I need your help here. I would love if you could help and register new accounts. Each account has a secret data. You just need to log in and wait to be hacked. My objective here is to hack your accounts and learn your secrets. So please scan the QR. The link is also available on my Twitter account, YonLabs. So register your accounts, but please remember not to use any sensitive data. Use only nicknames. Don't reuse any real passwords because those could be exposed. Okay, so I was going to say that I will wait for some users to be registered, but you are super quick. So we do have some accounts waiting to be hacked. So let me move to my evil server. Basically, that's the server I will do all the hacking from. This server is in the same subnet as our target Kubernetes cluster. And it happens that this server contains credentials to access our Kubernetes clusters, but those credentials are pretty limited. So basically, you see that I don't have full access. So let me see what I can do, and I'm cheating a bit here because I'm checking specific namespace. So you see that I'm able to create deployments and pods, and I'm able to exec into pods as this John Doe user. That's pretty handy, because what can I do now? Basically, let me see this everything allowed exec pod manifest. This is like fully misconfigured pod. So basically, it runs as a user root. We don't have any other users specified, and that's the default root user. Then we have this host network, host PID, host IPC set as true. And also we run in privileged mode, and we mount underlying new volume from our host node. And additionally, we schedule this pod on a control plane. So that's like crazy. So let's try to apply this pod, this manifest, and let's try to exec into this pod. That was full app namespace. OK, and I just want to access bash. Yeah, sorry for this one. OK, I'm inside this pod, but actually I'm on the node. As you see, this is this node instead of a container name. So basically, I'm almost on a host. Almost, because the only difference is the root of my file system. So I have access to the underlying file system, but under this host name, host folder. What can we do now? Basically, whatever we want, almost. Because we only need like to change root to host and get bash, and now we are fully on the host. So once you are on the host, you can do whatever you want. You can see all the processes running. Let's see if you are actually on control plane, and let's search for etcd. Yes, we are able to access etcd. We could like take down an entire cluster. We could install some extra malicious software, but we are targeting our demo application. So what can we do to hack this application? So let's take another look at this application, and let's see how authentication is done here. OK, so we have the session storage with a token, and basically this looks like JWT token. So let's take a deeper look at this JWT token. I'm using jwt.io page. And here I see that this token uses HS256 algorithm for digital signatures. So HS means basically HMAC with SHA-256, and this means like symmetric encryption. So with symmetric encryption, we have the ability to generate new tokens ourselves once we know the secret key. So we have different paths to compromise this application. Basically, first of all, we could learn and grab the secret. Once we know it, we can generate as many new secrets as we want. Another way is to get our hands on this token itself, so basically sniff the token somehow and intercept the token. Once we intercept a token, we can use it like freely. So those are like the main two paths for the compromise of your accounts in this application. So once we know that, let's move to etcd. I told you that etcd basically stores the state of the entire cluster. So once we access etcd, we could basically do whatever we want. Here, I'm looking for the parameter for etcd, which basically stores data. Nope. That's not etcd key file. Basically, that's like var folder. Okay, data dir. We've got it here. Because that's like the database which the files which etcd uses to store the entire state of the cluster. So here, yeah, we got it. That's the one. So basically, we are displaying this in the text format and looking for secrets. Okay, we've got our secret. And that's most likely the one, because it says like demo secret. Okay, I'm slightly cheating here. We have only one secret, but otherwise it would take like a lot of time. So you see that basically we have access to this JWT secret key. Let's try to use it. We are assuming that's the one for our demo application. So let's try to generate a new token, but with a different subject. Because as far as probably you know that for JWTs, this payload data, it contains claims, and subject, this one, usually is used to represent authenticated user. So lucky 7, and let's give it a try and simply use it. So to use it, I just need to replace my original token with this newly generated one. And Arda, you've been hacked. Are you here, Arda? Yes, you are. Thank you for such a nice cooperation. Okay, so what happened here? We escaped to Node. Basically, this one is based on the blog post by Seth Ard, and it explains in details bad pods configurations. So I highly recommend for you to get familiar with this blog post. And the problem we had during our demos that we had completely insecure configuration for our pod deployed in the cluster. So it was root, privileged, and those other parameters like host PID, host path, host network, and host IPC. Additionally, we used a user with limited permissions. However, this user was able to create new pods. So we could create this insecure workload by ourselves. And there was no mechanism, no like centralized policy enforcement to deny access to the cluster. So basically, we usually need some sort of admission hook just to reject misconfigured deployments or more generally resources. Also, it's important to mention what I've already told you, secrets management failure. Demo secret is not encrypted, it's only encoded, base 64 encoding. So basically, we could freely use it once we saw it in etcd. Let's move to another demo. This time again, we will escape to Node. But this time, we are switching to another user, Jane Doe. She has also like limited permissions, but this time is even more limited than our John Doe user had. So basically here, this time, this is app namespace, create deployments, and manage deployments, but we are not able to exec into pods. So basically, we can create this insecure deployment. The question is, how can we access it? Because that's kind of missing here. So let's move to this deployment manifest. And basically here we are using like a typical trick of hackers, reverse shell. What is a reverse shell? Basically, if you want to access a remote server, you basically SSH to the server, you provide your credentials, and you are given a shell. In this case, reverse shell is the other way around. So basically, instead of a client machine connecting to a remote machine, the remote machine connects to a client machine, this way bypassing any authentications or other steps. In our case, we are bypassing this credential checking, permission checking step in our Kubernetes API. So basically, for a reverse shell, I need another session. Why? Because if I need to like start a process listening on my evil server just to connect to it from inside our pod. Let me start another session. I'm logging to our evil server and basically just starting a new process using ncat just to listen on port 4444. And here you see that this deployment is going to create a pod and container which basically connects to our evil server on this pod and exposes bash. So let's apply it, and that's this one. You see that connection was received. This is like not a fully interactive shell, so we need to be careful. We don't have, for example, history. We have problems with standard error and other standard streams. We have only access to standard output. So there is some limitations, but still we can use it. We can do some reconnaissance. But basically, we know how this pod is configured. We have this host PID available. So basically, we can see everything what's running on the host. And especially, we can take a look at this #1 process. This is init process. So basically, we can escape to node via entering the namespace of this init process. This way, we will be acting as we were in the shell initiated by this init process. Just to show you that at the moment we are actually on the pod, you see that this is like this pod. This is our deployment. So let's try to enter our init process, all namespaces of the init process, and we want to run bash. OK, and now you see that we are on the actual host. What can we do now? Basically, if this were control plane, we could again access etcd, but we want to do something different. And this is not control plane. This pod was scheduled on a regular worker node. So we don't have access to etcd. So basically, let's see. I mentioned virtual network interfaces. Let's see what we have configured here. You see that we use Flannel as our CNI, and you see a bunch of network interfaces. Let's try to sniff traffic on all those interfaces. And I'm cheating a little bit here because I'm only sniffing this port 9090. OK, I've started, and now I have a kind request to you. Please refresh the pages in our web demo application. And we see some traffic coming in. Thank you for such an effective cooperation. So what can we do and see here? We can see those are too many. I will stop it now. And I'm searching basically for some tokens. OK. So we do have some tokens. And those are your JWT tokens. So let me copy one. And again, the old trick. And this time I'm logged in as Gunas. Are you here? Congratulations, you've been hacked. Thank you. Again, we've managed to escape to Node from our pod with more limited workload configuration, but still pretty much like root user, privileged mode, and host PID. Again, we were lacking centralized policy enforcement, and also you see that we need to take a closer look in our Kubernetes cluster into our networking configuration. Because we saw unencrypted traffic. If you take a look at our web demo application, this is HTTPS, but this is only to the load balancer. So inside the cluster, it is unencrypted traffic. Believe me, I don't remember how many times, but it was many. I had this discussion with junior DevOps developers that we don't need encryption inside our private network. We do. Because in case of exploitation, this is a series of misconfigurations in different layers. So we need to have this security paradigm, security in-depth paradigm that we need to basically secure each of our layers, and we need to be very, very thorough. Also, so unencrypted traffic, but also connection back to the evil server was possible. It's better to configure your network policies in such a way that any egress outbound traffic is not allowed if a pod doesn't need it. I have 2 more demos, and I think that we will do only one of them. So exposed credentials, and this is quite new one because usually I've done this one using my first account, like this first configuration with all or allowed pod. And I think I will do this because otherwise I will need too much time. But basically, what you need, let me show you this one. Basically, the only, I don't need this one either. Yeah, I told you I was doing this one like 30 minutes before our talk. I got this new idea for a new hacking. So basically, this is the only misconfiguration, like mounting full node volume, node root volume, and leaking some privileges in this volume. However, we do have like limited time, so let me exec into this, not this one, okay. I need to exec to this everything allowed pod, but I won't use any extra permissions. I only want access to the host volume. So basically, this was full up, and that was this version. I need to get bash just to make it a little bit easier. Or I will show you first. First, we want to, usually the first thing a hacker does is some sort of reconnaissance. So it's checking mounts, it's checking file systems for some leaked privileges, it's checking like some processes, etc. Here, I will only focus on our volume, and I will look for kubeconfig files. And basically, I found something here, so let me display it. And you see those are Kubernetes admin credentials. So to make it a little, so here I don't have access to kubectl, but basically I could install kubectl and make use of it just from inside the pod. But to make it easier, I will just change root, and I have this kubectl here, so I only need to export this kubeconfig variable, and I have full access to okay. Let me go to my cheat sheet. I think that I made some typo just to make it quicker. And yep. Okay, so basically, again, we could access all our secrets, but simply by displaying them via kubectl. And that's going to be the same secret we found via etcd. So just to save time, you know the drill. I would just access the secret and generate a new JWT token. You have a lot of information on this blog post via Bishop. I highly recommend it. With everything allowed configuration, like the sky is the limit, we have like full cluster compromise. Again, the same with privilege and host PID. With privilege only, there is still like multiple paths to full cluster compromise. With host path only, full cluster compromise is a worst case scenario. However, we could look for access tokens, search for kube configs, add custom, our own SSH keys, crack passwords, and etc. So a lot of bad things could happen. With host PID only, we could search for some leaked credential on the list of our processes. With host network only, we could sniff traffic, and there is a potential path to a full cluster compromise. And even in the situation when nothing's allowed, don't feel so safe, because there is like other ways to compromise the cluster. So that's only like the tip of the iceberg. I could go on and on this topic. But I would love you to remember one thing, like the Swiss cheese security model. We need this defense in depth principle to be implemented, and we need those different layers of security, because each layer covers the holes, security holes in other layers. So it's not about like 100 guarantee that nothing bad happens, because that's impossible, but we just need to be maximize our chances. And we need to make, for us good guys, easy to spot any behavior of bad guys, the hackers. And a fool with a tool is only a fool, so we developers, DevOps, we can't be fools. We need to use our tools wisely, and we need to continuously learn, and that's what conferences are for. So thank you for this opportunity to share learning tips, and thank you for such an effective cooperation.